Okay, let's look at some electron shell configuration questions here. So, first question, part A. Are these electron shell configurations allowed? All right, and so we have a set of rules for the different shells, subshells, orbitals, all these pieces, and so we're just asking if is 4s2. So when we have a configuration like this, we have N, and then the L is a letter, right? And then the number of electrons in that shell is up here. So number of electrons. I don't know what I want to call it. All right, and so in this case, then N is 4. So 4s to the 2. N is equal to 4. And L, when we have an S, we have our little cheat sheet here, but S is 0, P is 1, D is 2, F is 3, G is 4, so forth. So S is 0. So that S means L equals 0. Right? So when N is 4, can L be 0? Yes. And we have the rules here. Kind of you set N first, and then L can go from 0 to N minus 1, which is fine. And then in the L layer, then we have a certain number of electrons can only be in the L layer. Just looking, we can use this equation if we want to. So N sub L, in this case N sub 0, is 2 times 2 times 0 plus 1, which is just 2. So the most electrons that can be in a S shell is 2, but that's how many we have, so this is okay. Right? The next one, we've got, 3F4, so that means N equals 3, right? That's the first number. F means that L is what? Well, let's get back to our cheat sheet. So D is 2, and so F is 3. It's right after D. So F means L is 3. And so if we want to do our number, then N sub 3 is 2 times 2 times 3 plus 1, right? And so that's 2 times 3 is 6, plus 1 is 7, so we can have 14 in an F shell. All right, and so if we have 3F4, that part is okay. I guess one thing I forgot to check is the rule between N and L. Do we violate the rule between N and L? What does it say? L can go up to N minus 1. And so since N is 3, L can't be 3. The biggest L could be is 2 for this case, right? And so L max is 2 if N equals 3. So no, this was not allowed. X, bad, not allowed. Okay? Try the next one. N equals 5. D means L equals what? 2. So L is less than N, so that's okay. And then for the 10, all right, so can a D shell have 10? So let's check. So we just said L is 2. So N sub 2, the number that we can have in a 2 shell is 2 times 2 times 2 plus 1. All right, and so we've got 4 times 1. 4 plus 1 is 5 times 2 is 10. So we can have 10 in a D shell. So that one is okay. 5H40. Okay, so now again, N is equal to 5. N equals 5. Talking and running at the same time. Here we go. N equals 5. And then what is H? H says that L is, so D was 2, F is 3, G is 4, H is 5, right? So L equals 5. Uh-oh. So now we're in trouble again, right? Because we got N 5 and L 5, not allowed, right? And so nope, can't do that. So I thought we were going to get in trouble with the 40. We got in trouble with the 5s. What if we, let's just just check to see if we would be in trouble with a 40. Can we have 40 electrons in an H shell? So n sub H, or n sub 5, 2 times 5 plus 1. So this is 10 plus 1 is 11 times 2 is 22. So we would have been in trouble that way too. We have 2 ways to get in trouble on that one. So double X. Okay, not a lot. Okay, part B. List the values of L if n equals 5. Maybe we should have started with this, but anyway, we'll go with it. So B, if n equals 5, then L can be, we have just kind of copying the rules. If n is 5, L can be 0, 1, 2, all the way up to 4, right? So 0, 1, 2, 3, 4. Easy one. Okay. Part C. List the values of M and S if L is equal to 4. All right. So what are the rules here? So I guess we'll start with L equals 4. So N must be 5 or bigger, right? But we're not worrying about that. We're worrying about M and S. And so M can be 0, plus minus 1, plus minus 2, all the way up to plus and minus L. And then for each M, we'll have a half or a negative a half for S. All right, so M can go to plus or minus L. So for, let's see, how am I going to do this? So M can be 0, plus 1. Let's see. So 0, and then S can be 1/2 or negative a half, right? And then for plus 1, we get another 1/2 for S, or 1 plus 1 for M, and negative a half. All right, so we get different combinations of M and S like this, and so then we can go, we got a lot to write. Okay, so then we can go minus 1 twice, 1/2, negative a half, and then we can go plus 2 twice, minus a half, or I do plus and then minus, plus a half, minus a half, and then minus 2, plus a half, and minus a half. And we'll just keep on going, I guess. Plus 3, minus 3, minus 3, plus 4, minus 4, minus 4. Yep, because M can be equal to L. Yes, and so again, 1/2 minus a half, 1/2 minus a half. All right, so we get all these different combinations of M and S for an L equal 4 shell. All right, what was L equal 4? 0, 1, 2, 3, 4. So a G shell. G shell could have all those different combinations. Okay, I think that's good for C. For D, if n equals 5, how many electrons? List the first 20. Okay, so how many electrons in an n equals 5 shell altogether? We have the other equation here. And in an n shell, n sub n is 2n squared. So 2 times 5 squared, so there can be 50 electrons in an n equals 5 shell. So I mean, we can kind of see all these combinations here. For just the L equals 4 shell, we got 2, 4, 6, 8, 10, 12, 14, 16, 18, right? And so then we have L equal 3, L equal 2, L equal 1, L equals 0. So we can get a lot. So it says list the first 20. I don't know exactly what the first 20 are, but we can list 20. So let's kind of do a L. So we got n equals 5. So let's just kind of make a list here of n M, and S. And just kind of list them out here. We'll hopefully have room for these, the last ones over here somewhere maybe. Okay, so for n equals 5, then L can be 0, 1, 2, 3, 4. Very nice, we listed that out there. So when L is 0, should we do that? Or should we do the big ones first? Let's do the little one first. L equals 0. If L equals 0, which is an S shell, then what can M be? M can be 0, right? Plus and 0, and then it can't go up to 1 because it has to be equal to or less than. So M can be 0, S can be a half, L 0, M 0, negative a half. All right, so there's the two in the S shell, right? So now if L equals 1, we'll have several L equals 1, right? How many? We put in 1 into our equation for the L shells. We get 2 times 2 times 1. So 2 times 3 is 6. So we'll get 6 of those guys. All right, so M can be, I guess we'll start with 0. And then it can be 1. And then it can be negative 1. All right, and so again, 1 half, negative half, 1 half. All right, so this is the P shell, and it is 6. All right, so then what can L be? It can be 2. How many? We have 8 so far. 2, 2, 2. When n equals 2, what did I do there? When n equals 2, we'll have 2 times 2 is 5. And 2 times 2 is 4, plus 1 is 5, times 2 is 10. I kind of lost my 1 there. Something went wrong. All right, so let's push this up here so we can see a little bit better. And so I don't have all my 2's written here because we're going to have lots of 2's. But let's just kind of continue the table over here. So we got L, M, S, and we'll have a few more 2's. What did I just say? We can have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. All right, so what can M be? M can be 0. M can be 1. M can be negative 1. M can be 2 and negative 2. All right, because M can be up to L, but that's all it can do when L equals 2. And then we got all the 1 half, negative a half. 1 half, negative a half. 1 half, negative a half. All right, so all this is the D shell, and we can get up to 10 of those. So that is 8 plus 10, that's 18. Is at the first 20. So let's keep going. So now we can do L equals 3. We'll have a bunch of 3's. Right? So what can M be? 0, 0, 1, 1, negative 1, negative 1, 2, 2, negative 2, negative 2, 3, 3, negative 3, 3, 3, negative 3, negative 3, right? So we can just keep on going. So forth. Hopefully you see the pattern there, so you could continue on. And then in an F shell, which was L equals 3, we said we could have, well, we didn't do that. Oh yeah, we did that. We could have 14. There'll be 14 altogether. I didn't get all 14 that I've written here. But continue on, dot, dot, dot. We could get more. So hopefully you see how you can fill out the configurations, look at the quantum numbers for each. So n is 5 on all of these, right? 5. To get the whole set of quantum numbers. All these are 5, right? This is for the n equals 5 shell. Okay, we'll have to flip the page here. So what is the spectral notation for nitrogen? Spectral notation for nitrogen. Okay, so we're on day 38. Continued. Part E. Spectral notation for nitrogen. Whoops, sorry, off the page. And then for F is going to be spectral notation for calcium. Oh, get it on the page. There we go. So we just kind of get a little bit of information on the periodic table. So the periodic table, remember, is periodic. It has a period, has to do with the electron shells, right? So the first one is just the 1s. There are only 2 there, and then these are the layers that have p's that have 6. I'm sorry, the s's are here, and then the p's are 6 over here. So we got 1s, 2s, 3s, 4, so forth, and then we got the 2p, 3p over here, and then when they get bigger shells, we get more layers, and then these have to be squished in here. But the periodicness is when we get to the end here, we get a full shell, right? So we get a certain end shell as well. So we're looking for nitrogen. Nitrogen is here. It has atomic number 7, right? So Z equals 7, and so it's going to have, when it's just it's natural, or it's when it hasn't lost any electrons, it should have 7 electrons. Okay, so we'll assume that's what we're looking for here for its spectral notation. And so 7 electrons. And so our little cheat sheet has on here a little listing of the order of the shells, because notice they don't necessarily go in order. You got the 1s, and then the 2s, and then the 3s, and then a 4 jumps in, and then we go back to 3, and then we got 4, and then we 5, and then we got 4 again. And so the order they get filled has to do with the energy levels, and so it doesn't just necessarily go in order of our shells. Okay, and so to get up to 7, S levels have 2, right? And then P's can have 6. So if we have two 2s and a 6, that's up to 10. So we won't get all the way up to filling up the second P. So for N, we will have 1S, and the 1S level, so this N is 1, L is 0, and it will definitely fill up the first 2, and then we'll get to the 2S, right? And then I'll go ahead and write 2P. And I guess we can just check if we need 3S, but I don't think we're going to need the 3S. All right, so the 2S, 2, is going to get filled up. So now we got 4 electrons. And we need 7 altogether, so we need 3 more. So 2p3. How many did a p level? How many can a p level have? P means L equals 1. And so the number for the 1 is 2 times 1 plus 1. All right, so that is 2 times 3 is 6. So we didn't fill up the P shell, and so we don't need the next shell. We got our spectral notation for nitrogen. How about calcium? Where is calcium? Over here. So calcium has atomic number of 20. All right, and just looking, I mean, we can kind of see that it's going to go all the way up to the 4, N equals 4 shell, but we'll go ahead and practice here. So calcium, so Z equals 20. And so lots of times they would just say, take the noble gas over here and then add on what we get after that noble gas. But let's just go ahead and practice and write the whole thing out. All right, so let's just kind of write these down. Can we see them? Just barely, yes. 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P. That should be, hopefully that should be enough. So let's count to 20, right? So 1S, the S's can have 2, we already said. The P's can get to 6. All right, so we got 10, and then we got another S, so that's 2 more, so that's 12. And then we got another P, so that's another 6. So we got 12, 13, 14, 15, 16, 17, 18. We're getting close. 1920. All right, so let me double check. So we got 6 and 4 is 10, and then another 4 and 6 is 10. All right, so we don't need these guys. So there we have our spectral notation for calcium. And so it makes it through down to the 4th shell, and it fills the S level, but it doesn't get any of the D's or the P's, right, of the 4th level. Okay, so there's our notation for calcium. And I think that's all we had for this one.